So our next speaker is Kristine Connolly. Connolly. Yep, not my strong suit today. Kristine is with Kittelson and Associates. She serves as a senior engineer at Kittelson, and she holds a bachelor in civil engineering from Columbia and is a member of the TRB Access Management Committee. She's been instrumental in the development of the NHI Access Management course, and has also been instrumental in some of the pieces she'll be discussing today, which are the Multimodal Access Management Guide and the Multimodal Corridor Access Management Guide, which I've had the pleasure of hearing her speak about before, so I think you're in for a treat. Thank you, Kristine. Get this one. All right.
Thanks. Hi. I'm Kristine Connolly, and I am going to help you understand what some of the multimodal impacts of access management techniques are, which will hopefully, within the next 6 months or so, be at your fingertips with the Multimodal Corridor Access Management Analysis Guide. I like to call it the MCA-MAG because we fondly refer to the Access Management Applications Guideline as the AMAG. So I'm going to break this into 3 parts. First, I'm going to give you a background of the NCHRP 03120 project and the goals and scope of the project. Then I'm going to discuss that guide, which has the orange cover. Mark pointed it out yesterday morning if you were there for the welcome. And then I'm going to go over some of the results of the research. So Mark Bitorek was the principal investigator for this project, and at Kittelson we also had a team including Jim Bonison, myself, Paul Rias, and Bastian Schroeder. If any of you have worked with them in the past, they're spread out all over the country and beyond, once in Denmark. And our sub-consultants were Cutter, AECOM, Herbert Levinson, and Wright Rhetoric. There's also a panel, as with any NCHRP project. Many of them are at the conference this week. At least one, maybe 2. Gina here are in this room with us too. The project is, I should preface the entire presentation, the project is about 99.5% complete. So we're pretty sure everything today will still hold true later this month when everything is finalized. However, subject to change. All right, so the title of the project, the long title of the project, is Assessing Interactions Between Access Management Treatments and Multimodal Users. So we were tasked with identifying relationships between traditional access management techniques, most of which have been shown to benefit the safety and operations of vehicles, and then let's see what those effects are on multimodal users. And those are transit, truck, bike, and pedestrian. We focused both on operations and on safety. And the 2 final outcomes of this project are the MCA-MAG guide and the research report. Hopefully, the performance relationships that we developed will be able to be incorporated into other research documents, or resource documents, I'm sorry. So, we were tasked with, for many of these access management techniques that we looked at, we were tasked with including sites, both sites, which may be an intersection or a driveway, let's say, and corridors, which would include a larger length of a roadway. We focused on the access management treatments and their effect on 4 categories of multimodal users: peds, bikes, transit, and trucks. So this is just a good smattering of some of the access management treatments that have been identified. And really, this is the why behind this research project, is how do these treatments impact the 4 users in the center of that diagram? the need became pretty clear to identify these relationships. For example, what is the traditional access management purpose of right turn lanes? Can anybody venture a guess? I bet you've heard it a few times over the past 2 days. If you want to shout it out, I can repeat it. No?
To get rid of slower moving vehicles away from the faster moving vehicles.
Perfect. And we have a fancy term for that, speed differential. So we want to eliminate, or at least reduce, the speed differential when vehicles are slowing down to turn right at an intersection. And in doing so, you're going to reduce potential conflicts between those through vehicles and the turning vehicles. All right, and there's your answer. So why is that important? Well, when you do have these conflicts, that can increase as the volume going through the intersection increases. And then sometimes on higher speed roadways, that speed differential can be very significant. All right, well, what happens when at that intersection you have a bunch of pedestrians? Let's say 200 pedestrian crossings in an hour. This is a commercial area, maybe there's a mixed use, and you have a bunch of pedestrians. I'm not going to ask you to answer because the answer is we don't actually know yet, right? Or maybe there could be a mixed result, right? So when you add a right turn lane, the crossing distance becomes longer. But you're reducing the amount of things that the right turning vehicle has to think about at once when they reach that intersection, because they've already gotten out of the way of that car that may be coming up behind them really fast. What if there are 100 bicyclists per hour traveling on that same roadway? And what if there are also 8 to 12 bus stops per hour at that intersection? So the results of this study, and this is one of the techniques that we looked at, the results are meant to provide a quantitative and factual result that can be used for an engineer to discuss why or why not you should install a right turn lane at an intersection. All right, so project status. We submitted an interim report in January of 2017, and then the draft guide was distributed to the panel for review in August of 2017. More recently in March, we completed the draft research report as well as the draft guide, and the final research report and guide are anticipated later this month. They've been reviewed, we're just making some final adjustments. And then as Mark mentioned yesterday, you'll be able to see that shiny new orange cover next year. All right, so the Multimodal Corridor Access Management Analysis Guide, MC-AMAG, it's your new resource. So you've got the Access Management Manual, the updated version. You've got the AMAG, the Access Management Application Guidelines. Now you have a matching book to put on your shelf next to it that talks about the multimodal impacts. All right. So as part of this guide and the process for developing it, we did two things. We conducted a survey, and for the survey, we reached out to MPOs, state DOT contacts in access management. We reached out to other TRB committees, as well as a community of planners and engineers. One group we did not reach out to was stakeholders. This was also a collaborative effort with a bunch of acronyms, including, but not limited to, AASHTO, ITE, TRB, a bunch of them. And so 381 individual people actually responded to the survey. And this is a breakdown of where those people work and how they're involved in access management and transportation. So what did we find? We found that these treatments that are listed here are considered by those who were surveyed to need additional analysis, and this is only as it relates to multimodal users. This is ignoring the impacts on vehicles, passenger vehicles. And prioritization, and we broke this down by 3 different types of respondents: universities, consultants, and DOTs. The majority of these responses, not the vast majority, but a slight majority, was a DOT respondents. So the DOTs had a pretty good spread of what they considered needing more research, but they ranked median and median openings as a high priority. In comparison, consultants tended to rank roundabouts as needing more research for multimodal users. And then universities had a few extra responses that the DOTs and consultants didn't list, including unsignalized accesses, driveway consolidation, parking, and 2-way left turn lanes. The second part of our research was a literature review. So we looked at 33 Tier 1 documents to look at what access management treatments or techniques are being used, characterize and nail down what the shown effects are on operations and safety, and then identify the existing quantitative relationships so that they can be presented in this guide. So the survey, both the survey and the lit review, helped identify the research gaps and also helped develop the framework for what we provided in the guide. So if you've ever heard Mark speak, you know that there are more than 74 access management treatments identified. That's a lot. And those can be combined or chunked into 19 treatment categories. Here are those 19 treatment categories. For the sake of time, and so I can get to the results, which is what you're really here to hear today, I'm not going to read through these, but I'm happy to go over them later if you'd like. Here's the format of each module. So we created a module for each of those 19 techniques. And within that module, we described what that technique is, gave a summary of the multimodal operations and safety performance. So does it provide a safety benefit for any of these modes, or is it decrease the operations and safety of any of these modes? We provided general trends associated with each, as well as the quantitative analysis methods that exist today. And those quantitative methods were broken down by mode, so vehicle, pedestrian, bike, bus, and truck, and then also by operations and safety. Some of the techniques have a little bit more research out there than others. So here's what it looks like. I chopped it up a little so that you could actually read it on the slides, but you can imagine. And so this particular treatment is restricting left turn movements at an access point. So you'll see on the screen that's just a description of what does that mean in more layman's terms. And then we provide this table that really breaks down what research is out there on the effects. So an upward arrow means an increase in operations or safety. Down, decrease, and if you have the 2-way arrow, that means there's a little bit of both. So the research that's out there says, in some ways it improves, but in other ways it decreases the performance. And I think an empty circle is there's no documented relationship. So even with this technique, you can see there's a lot of areas where there is no documented relationship yet. Then we have a table that breaks down general trends, which is really a summary of the research that's out there, and you can see there's many references laced throughout the table. And following that, you break it into more detail. So what's out there on motor vehicle operations? And that continues. And then what about motor vehicle safety or pedestrian and bicycle safety? And then additional information and references. All right, the moment you've all been waiting for. Here's what we found. So here's a table illustrating what the, we combine a lot of the techniques, but in yellow you can see that there's a possible effect. The research really isn't there yet. These are the gaps in yellow. The gaps seem to be a vast majority for these multimodal users. For this project, we started with those 74 treatments and then worked our way down. So narrowed it down to those categories, and then worked with the panel and the results of the lit review and the survey to narrow it down to 3 that were ultimately selected for the study. And those were driveway design, right turn deceleration lane, and non-traversable median versus two-way left turn lane. We did combine that NTM versus TWLTL because we were curious what the differences were between those two, as well as just the impact of one alone. Driveway design, we did develop a study design for that technique, but in selecting sites for the research, we found that there were not enough non-downtown sites that had sufficient pedestrian and bicycle volumes to be used to develop quantitative relationship. So that is an area for future research, and a study design has already been developed. We looked at operations, which can be done through field measurement or simulation. And so for the two-way left versus NTM, we did use the, and as well as the right turn decel lane, we used simulation to develop our relationships. And for safety, we looked at crash reports for the median treatments. And then we looked at a simulation, and simulation really looks at conflicts rather than crashes. And that's what we did for the right turn deceleration lane. For the right turn decel, we were site specific, so looking at an intersection versus we looked at the whole corridor for the median treatments. All right, so what is a performance relationship? This is what we're trying to get out of this. It's an analytic model of the effect of an access management technique on the performance of a specific travel mode. So these can be qualitative or quantitative, and in most cases, quantitative can be more informative than a qualitative relationship. It could be a rule of thumb or a constant such as like a crash modification factor. It could be an equation, and this might have like a performance as a function of one or more variables. And it could be a method or procedure. So what if, in order to determine the effect, you actually have to go through a decision tree process? And so we developed performance relationships for the right turn decel, the NTM, the TWLTL, and then the kind of the comparison of the two, the TWLTL and the NTM. All right, so this table serves to identify existing relationships and as well as the measure by which we evaluated quantitative relationships. So if you can see it, hopefully the gray shaded boxes are relationships that were already identified, and in the white boxes were what we looked at. So this is for the right turn decel lane. We looked at, for operations, we were looking at overall intersection delay. And for safety, we looked at conflict frequency through simulation. And here are the results. So the factors, it wasn't just add a lane. We also looked at several other modifications, such as increasing the length of that lane, increasing cycle length, allowing right turn on reds, and so forth. And what we found primarily is that the installation of the right turn lane at a signalized intersection was found to decrease delay to all 3, bicycle, transit, and truck. And then it can be further reduced for transit and truck users if you lengthen that lane. How about, and I should note that was purely about operations. So now this is the safety side of things. What are the impacts on the safety? So in the first row, you can see that adding a right turn deceleration lane will increase transit-related conflict frequency. And that's related to the difficulty that a bus has after it's pulled off into the lane to pick up passengers and drop off, getting back across to the through lane. Conflicts were found to decrease for both transit and trucks with the increased length of that right turn lane, though, because it's a further separation of that conflict back from the signal. And the frequency of transit and truck-related conflicts increases with an increase in the bus stop frequency. So the more buses going through, the more conflicts there are. All right, what about the two-way left turn lane and non-traversable median installations? So in gray are the identified, and in white are the relationships that we evaluated through this project. And for this, we looked at travel speed along the corridor as well as crash frequency. And the crash frequency was based on actual crash reports that were provided by the Department of Transportation for these areas. So these models predict the safety and operational performance of these different modes as a function of street segment design elements, traffic characteristics, or signal control settings. So for, actually I want to go back. One more thing I want to point out. There we go. So for this, we developed a quantitative relationship for installing a two-way left, installing a non-traversable median, and then from those two separate equations, you can compare the two for any site that you're looking at. All right. And what we found here that was interesting is that an increase in traffic volume decreases decreases your truck operation performance by reducing truck speed. And this is consistent with the traditional speed-flow relationship. As you increase volumes, you're going to have a decrease in operations. In contrast, an increase in traffic volume is actually associated with an increase in bicycle speed. And that's based on prior research, not this existing research. That's why it's not in this table. And this relates to improved signal coordination that's usually provided in the high volume travel direction. All right. One thing that's not listed in this table is the models indicate that bike speeds are a little higher on streets with a non-traversable median relative to a street with a two-way left turn lane, with all other factors the same. And similarly, truck speed tends to be higher on a street with a non-traversable median than a two-way left turn lane. And I promise, this is my last slide. I've been told I'm running out of time, so we'll leave some time for questions. In terms of safety for a two-way left turn lane and non-traversable median, the predictive models indicate that transit-related crash frequency is smaller for a street with a two-way left turn lane relative to a non-traversable median. So this is a little counterintuitive when we said that the operations increase with the non-traversable median. So, and the reason this is that when you have that two-way left turn lane in the center, rather than a physical barrier, if there's any, a vehicle encroaching on the lane, that just provides one extra area to avoid collision. And that's why we've reduced the crash frequency with the two-way left compared to the NTM. All right, and as we found and located in this table, an increase in the lane width, shoulder width, bike lane width, or median width, so any of the widths of the roadways, reduces transit and truck-related crash frequency. However, an increase in access density has been shown to be associated with an increase in crash frequency. So, in summary, this shows that these tools can be used. A two-way left turn lane and a non-traversable median are not always going to be better one or the other in any situation. It's based on a variety of factors. So this guide and this research can be used to help you from a site-specific application to choose which might be best for your situation. Are there any questions?
What? Oh,
There we
yeah,
go.
yeah, thank you. Will there be spreadsheet models as part of the final product? Something that we can use to help analyze these?
So as an appendix to the final report, we are providing equations, but we haven't specifically developed a tool where you can input your factors to pop out a response.
Any other questions? Kristine, before you close out, I had a question. So you referenced that you had a research design to look at some other types of access management solutions. What other next steps are you looking at in terms of continuing to study the multimodal impacts of these different types of treatments?
Well, it's actually Hugo suggested, I don't know if it was at TRB or since then, in January, that these gaps be identified and provided to PhD students or master's students as potential areas for research in their programs. And I think that's a great way to fill some of these gaps, as well as other transportation professionals or future NCHRP projects.
Great. Thank you so much.